Get ready, because in this video, we are going to build real AI agent capability using MCP from scratch. We'll start by understanding what MCP is and why it's becoming a critical skill in modern AI development. We will go deeper in the overall MCP architecture. Then, we'll explore Fast MCP, set up our Python environment, and install everything step by step. Next comes the exciting part. We will develop our first MCP server live. After that, we'll connect this server with Claude Desktop to see how intelligent systems interact with real tools. Finally, we'll test the complete workflow in action. By the end, you won't just understand MCP, you'll be ready to build with it. Hello friends, welcome to Agentic Navigator. Let's first see each part separately in MCP. What is model, what is context, and what is protocol? Models are nothing but LLM. For example, GPT-4, Google's Gemini, Anthropic's Sonnet, and Opus, etc. Coming to context now. Context is the most important part in any AI system. Just think, you are in a meeting and you don't know the context about which topic the meeting is going. Will you be able to correctly provide your any meaningful input in that meeting? Answer is no. Similarly, if an AI system does not have context, it will not be able to generate right output. Think of context as the working memory of an AI agent. It can include user instructions, previous conversation history, system prompts, available tools, environment data, and even results returned from APIs. Can you imagine nowadays how many AI models are there? And if all the models are having their own separate rules of sharing the context, how chaotic and mismanaged it will become. Thanks to Anthropic, who came with a standard approach to share the context, and it was called MCP, Model Context Protocol. Protocol sits between model and context. The protocol defines rules and standard in terms of how context is shared, how requests are sent to models, how tools are invoked, and how responses are returned. So now, go to summary. Model Context Protocol, or MCP, is an open standard that helps AI models connect with external tools, data sources, and applications in a structured and secure way. Now that we are clear with MCP definition, let's now understand the architecture. MCP architecture has three main components. These are MCP host, MCP client, and MCP server. On the left side, we have the MCP host. This is typically your AI application or AI agent platform. Its main responsibility is to coordinate and manage one or multiple MCP clients based on user requests. In the middle, we have the MCP client. Think of this as a communication bridge. The client sends commands from the host to the MCP server and brings back the required context and responses. On the right side, we have the MCP server. This is the component that actually provides structured context, capabilities, or tool access to the MCP clients. So the overall flow works like this. The AI application, acting as the MCP host, sends a request through the MCP client. The client communicates with the MCP server, retrieves the required context or performs an action, and then sends the response back to the AI application. Now that we have understood the three components, host, client, and server, let's go a bit deeper inside each component. On the left side, MCP host, which can be an AI application such as Claude Desktop, an IDE, or any AI-powered tool. This host is where the user interacts with the AI. To communicate with external capabilities, the host uses an MCP client. You can think of the client as a connector that sends MCP formatted requests and receives structured responses. In the middle, we have one or multiple MCP servers. Each MCP server exposes specific capabilities. For example, access to local files, databases, or external web APIs. On the right side, you can see the actual data sources and tools, such as the local file system, enterprise databases, or internet services like GitHub and Slack. The MCP server securely interacts with these systems and provides relevant context back to the AI application. Now that we have a solid understanding about MCP architecture, it is time for most exciting part, that is, building a real MCP server. Before we start building our MCP server, it's important to create a dedicated Python virtual environment. This helps us keep our project dependencies isolated, avoid version conflicts, and maintain a clean and professional development setup. So first, Let's quickly set up our virtual environment. For this, you must have Visual Studio Code IDE and latest version of Python installed. Go to your VS Code IDE and run Python venv command to set up virtual environment. Now, we can see that virtual environment is created successfully. To simplify MCP development, we'll use the Fast MCP Python library. It provides an easy and structured way to create MCP servers, define tools, and manage communication with AI agents. This helps us build powerful, production-ready MCP integrations much faster. Fast MCP is a very popular Python library to quickly develop MCP server. If you start developing MCP server without this library, it will take lots of time to configure many stuff along with JSON RPC. But Fast MCP abstracts you from all those details and helps you develop an MCP server quickly. Using it is very easy. Just install the package, decorate your function with tool attribute, and that's it. Your MCP server is ready. Let's see this in action. Let's install Fast MCP library. First, we need to activate the virtual environment we had created. And now, we can install Fast MCP package by pip install command. We can now see that required Fast MCP package is successfully installed. Now that we have set up Python environment and installed required Fast MCP package, let's now write our actual MCP server program. As a first step, we need to import Fast MCP package and then create an instance of Fast MCP class. We need to decorate the functions with mcp.tool attribute. So, we have just defined two functions, add customer and get customer. Add customer method just adds a customer, and get customer method returns customer details based on the customer ID parameter being passed. Get customer method has two records with customer ID ID1 and 2. And your first and very simple MCP server is now ready with transport HTTP and port 8000. Now that we have our MCP server code ready, it is time to run this MCP server. We need to enter Python command followed by the name of the MCP server.py file. Once server is up and running, we will go to integrate this MCP server with Claude Desktop. Now we can see the MCP server is up and running with port 8000 over HTTP. Now it is time to integrate our MCP server with Claude Desktop. If you remember MCP architecture, Claude Desktop is the host in MCP architecture. To integrate with Claude, we need follow these two steps. First, we need to make MCP server entry into Claude_desktop_config file. The location of this file is at C users your username as a second step. We need to go to Claude Desktop and enable the connector for our newly added MCP server. And that's it. Now we can interact with our MCP server in a natural language. Let's make MCP server entry into Claude_Desktop_config file. Here is the syntax. We have to give any meaningful server name, command as npx, and arguments with type and URL of your MCP server. Let's complete the second and last step to integrate this MCP server. We need go to connectors option and enable our MCP server. Now that we have enabled our connectors, let's now try to get some customer records. Claude should now discover our MCP server and it should call appropriate get customer tool. We can see that Claude running our tool and is asking for permission to run the get customer tool. Let's approve this tool calling. It has now searched customer details for customer ID 2. So it is now fetching records for customer ID 2, that is Jane Smith. Now let's disable the MCP server integration with Claude. So now it should not return records for given customer ID. As we can see that, Claude Code cannot find the required tools in our MCP server. Whole code is uploaded to GitHub and the link is given in description and comment section for your quick reference. If you think this video provided any value to your learning, please like and subscribe to get more videos related to agentic AI topics.